Okay, so now let's identify the points, if any, where the function is discontinuous and state whether discontinuity is removable or not. So the first one, A, so f of x is equal to x squared minus 2x plus 1. So our first step we want to do is we want to find the domain, because remember your starting point of finding any values where the function is not continuous is first to find any values where the function is not defined. So in this case, if we think about what's our domain, so what type of function is f of x equaling x squared minus 2x plus 1? It's a polynomial. So the domain for every polynomial function we know is negative infinity to infinity. The beautiful things about this, because this is a polynomial function, well, if the domain's negative infinity to infinity, there's not any undefined values. So we can't find the behavior of undefined values. So in this case, because this is a polynomial, it is continuous everywhere. The beautiful thing, every single polynomial function is continuous everywhere. Now let's look at the second one. So f of x equals 1 over x minus 2. So first step, find your domain. So the domain of this function, what's going to break a rational function? Dividing by 0, right? So to find the domain, we want to solve the equation x minus 2 equals 0. Well, that just gives us x equals 2. So x cannot equal 2 in this case. So our domain then is negative infinity to 2, union 2 to infinity. So now, okay, we have some kind of discontinuity. At x equaling 2. So we know the function's not continuous there. We've got a break in our domain. But now we've got to figure out what type of discontinuity we have. Is it removable or not? So the easy way to answer that is, does the limit exist or not? If the limit exists, it's a removable discontinuity. If the limit does not exist as you approach x equaling 2, then you have a non-removable discontinuity. So we need to find the limit. So the easy way, remember, take the two one-sided limits. So as x is approaching 2 from the left of this function, 1 over x minus 2, this one, there's nothing we can do algebraically. And if you direct sub, you're going to get 1 over 0, not 0 over 0. So in this case, if we evaluate this, there isn't anything we can really do algebraically. Now you can go in, you can look at the graph, look at the table, see what's happening with the behavior. In this case, if you look at the graph of this, it's going to go, as you come in from the left, to negative infinity. Another way to think about this, if you're coming into 2 from the left-hand side, you're going to come in from a number that's smaller than 2, right? So this is going to be 1 divided by something smaller than 2 minus 2, right? So just say even 1.5. So 1 over 1.5 minus 2. So this is going to be 1 over a negative number, so you're going to be going to negative infinity. Similarly, now we do limit as x is approaching 2 from the right of 1 over x minus 2. And you're going to find it goes to positive infinity. So we know right away, just because one of these two one-sided limits is infinite, we know the limit can't exist, because remember, infinity is not a number. It does not exist. So we know this limit is x is approaching 2, 1 over x minus 2 does not exist. In actuality, what's going on here? We have a vertical asymptote. We'll talk more about that later when we're in chapter 4. But either way, because this limit does not exist, we know this is a non-removable discontinuity. So we have a non-removable discontinuity at x equaling 2. All right, what about C? So f of x equals x squared minus 1 over x plus 1. So again, to find our domain, we set x plus 1 equal to 0, x equals negative 1. Okay, so our domain is going to be negative infinity to negative 1, union negative 1 to infinity. So there's our domain. And then from here, so we know we have some kind of a discontinuity going on. There's some kind of a discontinuity. At x equaling -1. But again, is it removable or non-removable? So let's find out. So take the limit as x is approaching -1 of x squared minus 1 over x plus 1. We direct sub in. Okay, so that's the limit is x is approaching negative. So no longer a limit. We're direct substituting. So -1 quantity squared minus 1 over -1 plus 1. Well, what's -1 squared? It's 1. 1 minus 1 over -1 plus 1. That gives us 0 over 0. So that usually should be waving a big flag saying, I exist, I exist. This limit exists. So let's find this limit. So limit is x is approaching -1 of x squared minus 1 over x plus 1. Well, we've got rational, so think factor, so this becomes limit as x is approaching 1 of x squared minus 1, difference of squares, so x plus 1, x minus 1, all over x plus 1. Aha, the x plus 1's cancel, so that gives us limit as x is approaching 1 of x minus 1. And now we can direct substitute because we've taken care of our problem. We're no longer dividing by 0. So 1 minus 1, which is 0. Or sorry, -1. This should be the limit as x is approaching -1. So -1 minus 1, which then gives us -2. So because this limit exists and it's -2, this is a removable discontinuity. And if we wanted to remove this, guess what? We just define, so to remove this discontinuity, we simply define f of -1 to equal to the limit, -2, because that was the piece that was failing. So in this case, the limit exists. The function value does not exist, right? Because it's not in the domain of the function. So to make the function value exist and to agree, if we wanted to remove this discontinuity, you would define the function value to equal to the limit. And then it meets all three rules of criteria for the function to be continuous at that point. For the last one, so f of x equals absolute value of x minus 8 over x minus 8. So again, what's going to be our big issue here? Dividing by 0, right? So x minus 8 equals 0, x equals 8, right? So our domain is -infinity to 8 union 8 to infinity. For this one, now we haven't talked about an algebraic technique here to solve this. We haven't talked about how we could rewrite an absolute value. So the thing to think about is think about absolute value and how it works, right? What does it mean for absolute value? So let's think about what's happening at x equaling 8. If it was just the absolute value of x minus 8, right? That absolute, what is that? So think about it. That's your transformation, right? You're shifting this absolute value to the right 8 units, right? So that means that if you think about what the absolute value graph looks like, right? The regular absolute value graph would have the point, it'd be a V with the point at 0, 0, right? And in this case, we're shifting it over 8 units. So the numerator is just going to look like that. The bottom of the V is over at 8. So if you think about it, and then, so that's just the numerator, right? So what's happening here? To the left of 8, so let's think about the big question. If we know we have a discontinuity here, because we're dividing by 0, So we know there's something going on at x equaling 8. So let's figure out, is it removable or non-removable? How do we do that? We need the limit as x is approaching 8, right? For it to be removable. Well, so easy way to think about it, because we haven't talked about it. If we direct sub, limit as x is approaching 8, absolute value x minus 8 over x minus 8. Guess what? So that's 8, absolute value of 8 minus 8 over 8 minus 8. That's going to give you 0 over 0 when you evaluate through that. No dice, right? So now instead, let's think, okay, left and right-handed limits, because we don't have any other algebraic techniques we can possibly use. So limit as x is approaching 8 from the left of absolute value of x minus 8 over x minus 8. So let's think about what's going on here. If I'm on the left-hand leg of this absolute value, right, I'm on the negative value of it. So this is just going to be negative. So the limit still, limit as x is approaching 8 from the left, negative of just x minus 8, right? So the absolute value of x minus 8 when you're on the left-hand side of 8 is negative linear equation, right? It's negative x minus 8 over x minus 8. Well, now guess what? X minus 8's cancel. We're left with limit as x is approaching 8 from the left of negative 1. And what is the limit as x is approaching 8 from the left of negative 1? That's right, it's a constant function, so it is that constant. It's negative 1. Now, if this is a removable discontinuity, then the limit as x approaches 8 from the right will also equal to negative 1. So let's find out. So this is absolute value x minus 8 over x minus 8. Now we're over here. We're on the right-hand side. So we can rewrite absolute value of x minus 8 as the positive side of x minus 8 over x minus 8. Well, guess what? Again, they cancel, so this becomes limit as x is approaching 8 from the right of 1, which is 1. So does negative 1 equal to positive 1? That's right, it doesn't. So because these don't agree, then we know the limit as x is approaching 8 of this absolute value x minus 8 over x minus 8 does not exist. So because the limit does not exist, then this is a non-removable discontinuity at x equaling 8.